Hey guys, welcome back. So I already produced another video that will get published on YouTube, but I noticed that I have to reshoot certain parts. So what I'm now going to do is tackle a few smaller projects and try to fill in the gap until I finish the other video, which takes more time and editing than this hopefully will. Either way, I will do a few minor projects. I have a lot of things laying around that I have to finally do, like I have this really old electric screwdriver that needs to be repaired, some issue with the battery inside, or for example I have my old soldering iron that I would like to repair or convert to something else. I've got electric motors where I will try to extract the how's this called, the annealed wire, the annealed copper wire. Hopefully the insulation will stay as it is, and I have a lot of different other things. I won't do a whole lot, like I already made a video about salvaging components, but I have to do that, so I might as well involve a small part to waste a bit of my time. No, to be honest, I won't do that, but I have to do that, so they are lying over here. However, I might show you the components that I harvest off of these electronics. Maybe not, maybe this is not staying in the video. However, there are other things like these rechargeable batteries. I have to try them. There's a power supply for this. I have to try that. Have another power supply for the electric screwdriver. Here's another charger for 18650 cells. This one I already repaired, which originally was only a mechanical issue with this spring mechanism over here, but now it just won't do anything, so I have to take a look inside of here. Got another battery charger. This thing is freaking heavy, so we will take a look inside. I suspect there's a really heavy transformer inside. Then what else do I have? I've got a really old power supply where I will harvest components from. And last but not least, I've got this. And this is from an old dryer. This is the heating element to heat up the air that goes into the drum to dry your clothes. So I will harvest the resistive wire over here and either use this for a heating element in the future, or something else that I would be really interested in is to make a sliding resistor with a bit of graphite. So graphite contact, resistive wire. Maybe this works, maybe it doesn't, and I probably will include it in this video. However, I think that this will not only be one video, but a few, so maybe not everything will come in this video. And for example, if this is going to work, so extracting this and it's going to work that I use graphite for a sliding resistor, I might do a video on its own. Same goes for the soldering iron, the repair. And I will explain what's wrong with it or why I have to take a look at a certain component when I just do that. So now I have to get rid of everything and start with... What am I going to start with? I think I'm going to start with the really old battery charger. This thing is freaking heavy. Because these are old electronics, I am going to wear some gloves. In general, you should wear protective gloves like these ones to make sure that you're not getting any dust, heavy metal dust on your hands. Because, for example, lead, but also other heavy metals, they are not really good for your body. And it's not like touching electronics once or twice is really harmful, but over time, the more you work with electronics, the more you get it on your hands, and well, then it gets transferred through touching yourself, touching in your face or everywhere else. It just gets spread all across your body, and it's really bad to get it in your eyes or mouth or something, because then it gets pretty fast into your system. And these screws, they are a certain weird protection screw, so I have to grab another set of screwdrivers, because at one point I modified a screwdriver so I can loosen these. I think, yes, that's it. So you need a flathead screwdriver with a cut in the middle to be able to loosen these screws. Yeah, that works. Perfect. So this goes to the side, and I just lost the bit. Oh, god damn it. Oh, come on. Where is it? Help, please. Shoot. No, I did not just lose my modified screwdriver bit, but instead I'm going to make one. No, to be honest, it's gone. I can't find it. Now the problem is, we have, I don't know the exact time, but it's pretty late, so I can't use electric tools, but I would like to start with that. Should be fine. I mean, it doesn't really take a long time to modify it. Just need my rotary tool and a metal cutting or a metal grinding bit. I need a bit of power. By the way, power, it's not powered on. And now, that's not the way to do it. That's a bit unsafe. So I need this. Okay. Right, so that's how you make one of these. I mean, you will probably never need one, but that's how you do it. So now let's pretend this never happened and I did not just wake up my neighbors. And by the way, no, it's totally fine. It's not too late. Now let's do the same thing without losing the bit, and I have to adjust the camera. So, like this, and I have a good idea. I've got some magnets. I hope they are small enough so I can fit one inside of here. This is going to work, I think. Is it? Oh, come on. Oh. Okay. Yeah, it fits. So, what am I going to do? Easy thing. I need a bit of glue. Use the bit, bottom, dab of glue, not too much, and then, no, don't stick there, slide in. Slide in. Oh, come on, really? How am I going to, like this? Got it. It's in. No. Right. It's not touching the back. Oh, that doesn't work either. Okay. Just like that. And then be quick. Was too slow. There shouldn't be any glue inside. Otherwise, I can't remove the bit again. Okay. Glue on top. Hold it in place. Be quick. Right. So I will just use it, and hopefully it sticks by the time I'm finished. Now I should remove these small glue dabs on my table. That should be fine. Oh, right. Okay, done. Now we can go ahead and disassemble this thing. Finally. Okay, so does it come apart? Yes, it does. Something on the bottom is holding it in place. It's not this. It's not that. Something else. Oh, I'm missing a screw. There's something. Yes, I am missing a screw, I think. Or not. What's in here? Oh yeah, there's another screw. Okay. Now we can finally disassemble it. And just as I thought, a big, chunky transformer. That's a really old charger. I would not recommend anyone using a power supply with a transformer inside, because this means these power supplies are really old. Not because of transformer. I mean, yes, they are less efficient and pretty heavy, but anything nowadays that has a transformer inside is just old. And that looks interesting. So can I remove this? They are soldered, but there's a screw, so I can just remove it as one part. Alright, so this is what's inside. Big transformers, a 2-wire contact, a few LEDs, these contacts, and a big IC. Now this IC is really hard to read. So ST, what is ST? I just forgot that. What is ST? Well, it's a company that's known to me. There's something that just makes me not being able to see it. I have to clean the IC, and I will do so with a bit of isopropanol. Hopefully this removes the small stain that prevents me from reading the number. Okay, some color comes off of the IC, so maybe this will do the job. It looks like HCF4060BE. I have to take a look at the datasheet. I've got no idea what this is. I'm not really into charging batteries. I think it's most likely a proprietary IC that handles charging the... what is this thing made for? NiCad batteries. So, proprietary charging IC, probably. So, here's the thing. I don't know a whole lot about this kind of charging circuitry, and I don't need it. I mean, I have other rechargeable batteries, but they have their own power supply and this small box that's handled charging, so I don't need this. And this is also much older. I can tell it's much older in design and everything, although there is no marking. But the other one already has a switchable power supply, so I assume it's younger, and the other one should work. I just have to make sure that it actually does. What I will do, however, is remove the transformer. That can be handy at some point. And I will take a look at the IC datasheet, and I will include it in this video, at least a quick shot. But other than that, there's not a whole lot to be salvaged. I mean, 2 capacitors, and the LEDs are not really worth it. I mean, honestly, nothing of this PCB is worth it. I will just remove the LEDs to get the heat-resistant insulation from the legs, and maybe the IC if it's anything but a proprietary chip. So let me just remove the transformer and set the whole thing aside for later inspection. Now here's the datasheet for the HCF4060BE, and this was a real surprise to me. I thought this might be a dedicated IC for charging batteries, but what it is actually is a 14-stage triple carry binary counter divider and oscillator. So this IC is actually worth saving. So what I'm going to do is desolder this IC, and this comes into my collection. I don't actually need such an IC. The only thing that is really interesting is the oscillator part. But beside that, there's not a lot of description. I mean, everything that is here, it's the HCC4060B and HCF4060B are monolithic, integrated circuit, whatever, and there's nothing specific to charging batteries. There's a lot of magic, in quotation marks, going on the PCB. I think has something to do with the transistors, and the IC gets triggered if a certain voltage is reached, the transistor gets turned off, something like that. And this datasheet is from September 1988, so this IC is indeed really old. And that actually didn't struck me first. What struck me first was when I scrolled down that this page just was tilted. So this suggested to me that it's not a datasheet like you get for newer ICs, but was actually photocopied off of the physical paper. And then I searched for a timestamp, well, a date, and here's September 1988. So indeed, it's a really old charger. And to finish this video, I'm now going to take a look at the power transformer. It has 5 different secondary leads. So this suggests to me that we have one starting point of the secondary winding, first midpoint, second midpoint, third midpoint, and end point. And what I'm thinking is, if you insert one battery, just 2 get connected to the charger. If you insert one battery, 2 get connected. If you insert 2, 3, and so on and so forth, until we reach the limit. And I already got rid of the housing, so I can't show you how many it was. I think it was 4 batteries. 1, 2, 3, 4. Yes, I think that's the case. But to be 100% sure and to actually know the voltages for each secondary winding, I'm first going to measure, and then I'm going to connect to mains power and see what voltage I get. Now, where are my test leads? Just going to use these. I'm currently in resistance measurement, no need for continuity or something like that. So first blue wire, yellow wire, we have a resistance and a connection, 29 ohms. This should have a higher number. No, it has not. Interesting. How's that? The same. And this has higher. So what I'm currently thinking is these are the the live and neutral equivalent after isolation. So we have 3 midpoints. They share the same resistance and they almost have no resistance against each other. So this means my assumption was wrong. We have 3 essentially same middle point and 2 main wires. But I'm not 100% sure why they did that. Let's take a look at the PCB. I still got it, so let's see. Battery voltage comes in, goes through diodes, and oh, that's interesting. So these 2, blue and yellow, these 2, they directly go through one single diode from over here all the way down. So one through diode goes all the way down, the other one just connect, no, wrong, sorry. So the yellow one goes down here through this diode. It's this point over here from this pad through a resistor, the resistor over here, and connects to this part. So yellow is connected over here through diode and resistor. Blue, however, this over here goes down. We have 2 different diodes connecting over here. Yes, and separated to 2 connections going. One goes all the way down here to 1 transistor, and the other connection goes over here, which is connected through another diode. Sister, oh, magic going on. Well, quite interesting, but nah, I'm not going to deal with that. I just want to know what voltages for each test lead, so I know if it is usable for a certain project or not. And to do so, I need my safety outlet. This is really, really dangerous because we have solder joints completely exposed. This is not what you should do. However, I'm going to do exactly that, except that I would like to use some tape just in case. Just in case I'm a bit dumb. And also to be able to set the transformer like this, but still it could poke through, so cardboard, yes. So cardboard over here, another piece, tape like that, transformer on top, perfect. Totally fine, absolute safe, I do not recommend. So let's straighten these. And different test leads just to be extra safe. So we are suspecting AC voltage, and I have to disengage the kill switch. And now let's turn it on. 9.8 volts AC. Here we have 14.36 volts. 18.96 volts and 28.7 volts AC. And now that's interesting. The voltages rise with each of the leads. So the first two, I think, was 14 volts AC, or no, 10 volts AC, and by the last one it was 24, 28 volts. I already forgot. And with each lead, secondary lead, it got higher, which was what I suspected originally. But why was the resistance between the first and these three wires almost the same? I mean, yes, 1 or 2 ohms, but 1 or 2 ohms more resistance? Does it really jump 5 volts? So here's the thing. I thought each resistance has to jump up a certain amount, but the middle 3 test leads are within 1 or 2 ohms resistance, so I'm amazed by that. Now that's it for today, and I have to say I'm really amazed by the readings of the secondary winding. I thought the resistance has to jump up each time you want a higher voltage, because you have to have more turns of wire, which adds resistance. So I suspected the highest resistance between the outer two, and a resistance jump from here to here to here, and so on and so forth. But apparently that's not the case, and I therefore have to revisit transformer physics, because clearly something in my head just doesn't add up. But hey, I'm human, and last time I had to deal with electronics and physics is years ago. I hope you liked the video, and if you did, please leave a like, comment down below, and I hope to see you next time. Bye!